Okay, so next here I'm going to look at 2009 question 6, C in particular and E, but I'll just do D because it's in the middle. So straight chain molecules of C13H28 occur in the kerosene. I'm told upon cracking that I end up with the C2H4 molecule, so I take that away. So 2 carbons from 13 gives me 11 left, and 4 hydrogens from 28 gives me 24 left. And then I'm told I also make a C4H8 molecule. So a C4 minus a C11 gives me a C7 and then a H16. So that is an alkane. So identify this unbranched alkane molecule and state its octane number. So this here, 7 carbons, heptane, one of my octane numbers, big one, 0. Okay, the other one, remember, 224 trimethylpentane, which has an octane number of 100. They're my reference hydrocarbons. Next, then you're asked to name 2 other processes carried out in oil refineries to modify hydrocarbon structures. So firstly, we make isomers. So that's one of the processes, isomerization. And secondly, then we have reforming. Okay, and remember, they are also 2 things that increase an octane number, which is also dehydrocyclization. Okay, so making a cyclical compound, removing hydrogen. Okay, so isomerization and dehydrocyclization. Part E then, the combustion of one of the C4H8 isomers is described by the following balanced equation. So I have C4H8 plus 6O2, and that goes to 4CO2 plus 4H2O. And my value there is minus 2,710. Now, this is actually the same as the ones I've done before, 2015, 2012. It's just a little bit easier because you're actually given the heat of combustion here. Again, then, we're told that the standard heat of formation of water, H2O, and carbon dioxide is minus 286 and minus 394 respectively. And we're asked to calculate the heat of formation of the C4H8 isomer. So in this case, C4H8 is 4 carbon plus 4H2. So that's the overall equation I'm looking to get. It's the exact same here, except we are actually given our heat of combustion. So H2 plus a half O2, and I have C plus O2. Okay, so they are my equations. So what I do here is I look left-hand side, right-hand side. So the first thing I have to do here is reverse. So I end up with 4CO2 plus 4H2O, and that gives C4H8 plus 6O2, so plus 2,710. Looking up here, H2, I need 4, so I have to multiply this equation by 4. So 4H2, 4 over 2 gives me 2O2, and that gives me 4H2O. Okay, so minus 286 then, multiplied by 4, gives me an answer of minus 1144. Finally then, C, I've only one C here, I have 4 on the top, so again I have to multiply this by 4. 4C plus 4O2 gives 4CO2. And again, minus 394 multiplied by 4 gives me minus 1576. Okay, so comparing what I have on my left-hand side to my right-hand side. 4CO2 cancels with 4CO2. 4H2O cancels with 4H2O. If I look here, 2 and 4 oxygens is 6. So 2 and 4 is 6, cancels with my 6. And that is all that will cancel. So I am now left with 4C plus 4H2 gives C4H8. So if we look at what we have here, 4C plus 4H2 on my left, giving C4H8 on my right. That is what I'm looking for here. So what I do now is, these are my values. So minus 1576, minus 1144, and then plus 2710. And that gives me an answer of minus 10 kilojoules per mole.